Nobody called it. All right, anyway. So does anybody have any questions from the homework? Anything you want to see? We good? All right. If y'all good, then let's move on. It's gonna be a real easy day. We're gonna talk about the central limit theorem. Coolness. Literally, like this is like the last homework that was posted, and I accidentally posted homework too early. So y'all might have done the homework already. Oops. But here it is. This is how to do it, right? So the central limit theorem. The X distribution, given that X is normal. All right. So in the last section, we began a study of the distribution of X bar sample mean values, where the sample mean was the mean length of the 5 trout caught by the children at the Pinedale Children's Fishing Pond, right? So let's consider this example again in light of a very important theorem in mathematical statistics. What's good, man? Hmm? Yo, what's that? The iced tea? Yo, I got that iced tea too, man. Yo, it's just less, dude. Yeah. That Chinese iced tea is fire, man. But yo, the Starbucks iced tea, love this shit. Yeah, in the library, do you have Starbucks? Mhm. Yeah, yeah. That's why you always see me with Starbucks. Yeah. Facts. Facts. But the last time I went there, I asked them about the iced tea and they said they made it. Then they showed me. I was like, yo, yo, I love their tea. Their green tea is amazing. Yeah. I'm I'm gonna give y'all my recipe, right? This is how I get my green tea, right? So no ice, no water, right?
No ice, no water.
Yeah. So when they make the tea, right? Like they have like a concentrated strong batch, and then they pour like a inch in there, and then they just fill it the rest of it with water. I'm like, nah, give me that concentrated batch.
Oh.
Yo, that joint is amazing. Nothing. No ice, no water. I don't want nothing. Just give me the way it is, you know? Like nah.
No.
Yeah.
No.
Yeah.
Yeah.
Yeah. Nah, but they have a peach version of this and all of that. They have flavored versions that are nice. Yeah. But for me, nah, just straight up. Yeah. All right. Theorem 7.1. So for a normal probability distribution, let X be a random variable with a normal distribution whose mean is mu and whose standard deviation is sigma. Let X bar, your sample mean, right, be the sample mean corresponding to a random sample of size n taken from the X distribution. Then the followings are true. That the sample mean distribution, X bar distribution, is a normal distribution. The mean of the X bar distribution is mu. The standard deviation of the X bar distribution is sigma divided by the square root of n. So we're going to conclude this theorem, right, that when X has a normal distribution, the sample mean distribution will be normal for any size n. Furthermore, we can convert the X bar distribution to a standard normal Z distribution using the following formulas. All right. So the mean for the X bar distribution is mu. The standard deviation for the X bar distribution is going to be sigma over the square root of n. And our Z formula is now Z is equal to X bar minus the mean for the X bar distribution over the standard deviation for the X bar distribution. Or you could say X bar, sample mean, minus the population mean mu divided by the standard deviation divided by the square root of n. All right. Good news. You don't have to memorize this. It's on your formula sheet. Let me show you. This is going to be fire. As soon as I figure out where it is, here it is. This is chapter 7. That's right. So you go to your formula sheet. Let me scroll up so we verify it, right? We're on our formula sheet. And then go down to where it says chapter 7, right? Here it is. You got the mean for the X bar distribution. Bam. You got the standard deviation for the X bar distribution given, bam, and then you have the standard score for X bar. Boom. All right there. So you don't have to memorize nothing. You use this to do your homework. All right? This is that good news, that good stuff. All right. Just to recap, N is your sample size, mu is the mean of the X distribution, and sigma is the standard deviation of the X distribution. All right. So this theorem is a wonderful theorem. It states that the X bar distribution will be normal provided that the X distribution is normal. The sample size N could be 2, 3, 4, or any other fixed sample size we wish. Furthermore, the mean of the X bar distribution is mu, same as for the X distribution, but the standard deviation is sigma over the square root of N, which is of course a smaller, right, standard deviation than the original, right? And then let's look at an example. Don't worry, this example is mad easy, right? So probability regarding X and the sample mean. My fault. Sorry if you were still copying. So suppose a team of biologists, it's similar. We're using the same example. Yeah. So suppose a team of biologists, right? So we're not talking about Susan. We're talking about a group of biologists, right? They're studying the Pinedale Children's Fishing Pond, right? Let X represent the length of a single trout taken at random from the pond. This group of biologists has determined that X has a normal distribution with the mean of mu is equal to 10.2 and inches and a standard deviation sigma of 1.4 inches, right? So here's our first question. What is the probability that a single trout taken at random from the pond is between 8 and 12 inches long? All right. So let's do that real quick. We're going to come back to B. And you know what? I should have keep forgetting my highlighter. Where my highlighter at? Here it is. Got to highlight the important information. Mu is equal to 10.2. Sigma is equal to 1.4. They want to know between 8 and 12. All right, there we go. Got my important information there. I'm just hold it right here. So I have a chance to write it down. All right, so mu is equal to 10.2 and sigma is equal to 1.4. They want to know what is the probability, right, of 8 less than X less than 12, right? Because they want to know between 8 and 12 inches, right? Now, we got a problem, right? Here's our problem. Let's go back to the formula sheet for a second. I want to change this to a normal distribution, right? So you already know I'm going to use the standard score, right? Z equals, right? But here goes my problem that I have. Let me go to the normal distribution table. All right, here we go. You see this drawing right here, right? Let's read this bottom statement here. The table entries for Z is the area to the left of Z. That means that all of these numbers that I have inside this chart are for less than. They're not for between, right? So I have to modify this question that I got, right? So let me modify the question real quick. All right. So what I'm going to do, I'm going to take the big number, so probability of X less than 12, and I'm going to subtract that from the probability of X less than 8, right? I'm just going to draw a quick diagram so you could see why I'm doing this. Right? Let's say that the mean here was 10.2, and then this is 12, and then this is 8. Let's just pretend, right? So I want this area in the middle, but I can't do that, right? So what can I do? I could take the area to the left of the 12, all of this, and I could subtract the area to the left of the 8. And that will leave me with the area in the middle, which is what I'm looking for, right? All right, anyway, let's turn this into z's, right? So this is going to become the probability of z less than x minus mu over sigma minus the probability of z less than x minus mu over sigma, right? Keep going. This is going to become probability of z less than my first x is 12 minus my mean, which is the 10.2, divided by my standard deviation, which is the 1.4, minus the probability of z less than, this x over here is 8 minus the 10.2 over the 1.4. All I'm doing is I'm just plugging it in. That's all I'm doing. Just plug it in and that's it. All right. Questions about this so far? We good? All right.
Yeah, which,
Mm-hmm.
so you gotta do it for next time. Okay.
We got more. We got more. But just setting this up, is there any questions on how to set it up? We go from X to Z. Mhm.
For the standard.
Mhm.
The C part, but
Mhm.
we lost when we got to like the second one.
The 8.
Yeah.
So look at the pictures. That's the reason why I'm doing the 8, right? I can't find this in the table, right? The table doesn't give me in between. The table only gives me less than, right? So I have to take all of the area from the 12, which is this, and then I have to subtract it, right, from the area to the left of the 8, which is this. That's what I'm doing right now. All right. And then the rest of it is just simple math, plug it in the calculator and we're good. Probability of z less than. Are you guys comfortable with typing this in the calculator or y'all need to see how it's done? I'm gonna take y'all silences, y'all good. All right. All right, y'all silent, so that means that y'all good. Y'all could do it in the calculator. So I'm gonna just cheat and use my Excel up here. No problem with me. So 12 minus 10.2 divided by my 1.4. Bam. So I got my number right here. So this is 1 point. Now remember, for the table, I need two decimal places. I need two places after the decimal. So I need the tenths and I need the hundredths place, right? But I have to consider what the thousands place is to round off the hundredths place. So this is 1.285. So because of that 5, I'm going to round the 8 up to 9, right? So this is 1.29 minus the probability of z less than, I don't even know what this one is. Let's see, this is going to be 8 minus 10.2, right? Close parentheses divided by 1.4. I could tell you it's negative though. So this is going to be negative 1.57. And it's 57 because the thousands place here is a 1, right? So just going to round that off. After we get this, light work. Just look it up in the table, subtract the two answers, and we good. So I have 1.29. So let me turn to my table real quick. I'm looking for a positive 1.29. So I'm going to go down to the positive table right here. Looking for 1.2 right here. I found the 1.2, and then the 9 is the last column over here. So where do they intersect at? They intersect right here. That's the point 9015, right? Point 9015. All right, so let me write that in. So I have point 9015, and I'm going to subtract that from, this is a negative 1.57. So let me look that up in the chart. All right. So I have a negative 1.5. So I'm going up. Right here, I found negative 1.5. And then my hundredths place was a 7, right? So here's a 7 up top. So now I want to look at and see where do they intersect at. They intersect right here at the point 0.0582, right? 0.0582. So let me write that in. 0.0582. After this, just a little subtraction, and we done with the whole question. 0.9015 minus 0.0582. What do I have? Final answer, 0.8433. Easy, right? So? Got you. I mean, you don't got to remember the formula, you know? Yeah.
Question. You always gotta put the largest number first?
Yeah.
How it's 8 to 12, and then it was 30 to 50.
Right. 50 first. Yeah. And then 30. Yep. So we good? All right. I can hear Danny's question. All right. How I do this in the calculator. All right, let me show you. So let me show y'all. Wait. I done clicked on something wrong.
Right, I didn't even realize that.
Uh, good. No. Oh shit. Every time I open my calculator, I got mad ads.
Yeah, we don't show our words, just that you might give us the full point.
Huh? What?
We don't show our words, just
Mhm.
like that, you might give us the full point.
If you give me the right answer, I give you the full points.
Oh.
If you give me the right answer, I give you the full points. You know, I recommend you show your work because if you're wrong, right, then I'm looking to give you extra points. You know, but if you just have a wrong answer, it's binary. It's just wrong. You know. But with the work, I could be like, "Oh, my fault. Like you ain't round off the 8 to a 9, so you know, like take off a point for that or something." You know. Yeah. Where's my there? Computer acting slow? You gotta work at my speed. You know, I'm clicking, I'm opening, and all that. Go ahead. You have it already. Look, there's a way to look for it online. I'll show you. I'll show you after class, but there's a way to look for it online. Yeah, I got you. It's weird. It's something new that I didn't even know what to tell y'all at first until I learned about it. All right, so let's say I wanted to do this in the calculator, right? I just need this third line right here, the z less than 1.29 and the z less than negative 1.57. So this is how you would do it in the calculator. So if you have the TI 36X Pro, you're going to press second, then you're going to press the data button, then you're going to go across the distribution. If you have one of these, right, you go to second distribution, right? You go down to normal CDF, all right? Normal CDF. Now hold up, I forgot something. Hold on. Whenever you're using the calculator, you have to draw your distribution. That's really important. Hold on. Really? You had all this time to load and now you want to freeze up? Come on. All right, you have to draw your distribution if you're going to use the calculator, right? For a normal distribution, you know, your mean is 0, right? And then we have our positive z, which is the 1.29. We have our negative z over here, which is a negative 1.57. And we want this area in the middle, right? What you do is you pretend that you're standing in the distribution. This is you. You're standing in the distribution, right? Put a little smile on the face, right? Now, whatever is to your left, that's your lower bound. Whatever is to your right, that's your upper bound. And then you just plug in the numbers in the calculator, right? So lower bound, this is going to be negative 1.57. Enter. Upper bound is going to be the 1.29. And of course, your mean is 0, your standard deviation is 0, paste, right? And then that's it. Same answer. That's how you do it in the calculator. All right. This next part is for Carmen. You got to remember this, right? So you're doing normal CDF, and then you have your lower bound, your upper bounds, your mean, and your standard deviation. So for us, that was normal CDF, and then that's the negative 1.57, comma, the 1.29, comma, 0, comma, 1, and then you have your full answer, 0.8432670,433. And that's it. That's the full calculator work. And that's how you show work for your calculator. Well, got you. For this calculator, right? Or for the 36X Pro, which one? 84? All right, yeah, so same thing like this. So what you're gonna do, you're gonna press second, and then you're gonna press distribution right here, DISTR. Then you just go down to where it says normal CDF. And then you just fill out this little menu right here. What's the lower bound? What's the upper bound? What's the mean? What's the standard deviation? And then you go down to the last thing that says paste. And then you hit enter again, and you get the final answer. That's it. Cumulative distribution function, right? It means that you're adding up all of the values, right? Whereas when we did PDF, probability density function, that's just for one situation, right? Yeah. So that's like when we did the binomial distribution, right? Like when we were just finding the probability of like 5. Then we use PDF. But you use CDF when you want to find multiple and add them all together, right? But for normal distribution, we're always going to use CDF. We're never going to use normal PDF. Always CDF. Mhm. So normal CDF we use binomial PDF, and we use binomial CDF, right? PDF is for one situation, CDF is for less than or equal to, right? But with normal, because we have that lower bound, upper bound thing, we don't have to worry about just less than. We can go straight in between and get the answer. Right? So we good? We'll get into that. Yeah. We good? All right. So question B. Question B says, what is the probability that the mean length X bar of 5 trout? Hold on, this requires a marker real quick. 5 trout, right? Taken at random is between 8 and 12 inches, right? So now what's different about this question? I have an N, right? So my N is 5, my sample, right? My mean is 10.2. My standard deviation is equal to 1.4, right? So same question as before. I want the probability of 8 less than X bar less than 12. Same thing as before. Same issue as before too. Can't look that up. Gotta do the big minus the small. So this becomes probability of X bar less than 12 minus probability of X bar less than 8. Same thing, right? I'm not going to draw the pictures, but it's the same for the same picture, same reason and all that. So this is going to become probability of Z less than X bar minus mu over sigma over the square root of N, right? Minus probability of Z less than X bar minus mu over sigma over the square root of N, right? Very simply, how did I know to use this formula? In this question, I was given a sample size. I was given an N. So I'm going to use the formula with the N. Very simple, right? And by the way, where did I get this from? I'm not making this up. I'm literally just copying. All right. Literally just copying from the formula sheet. Here it is, right? Chapter 7, right there. And then we write down here standard score for X bar. That's it. After that, the question is the same. Plug in the numbers, boom, 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 look up the answers, and then that's it. So let's do that. So I'm just going to plug this in. So this is going to become probability of Z less than 12 minus my mean, which is 10.2, I think. Yep. Over my standard deviation, which is 1.4, over the square root of N, which is 5. Minus probability of Z less than 8 minus the mean, which is 10.2, over the standard deviation, which is 1.4, over the square root of 5. Because I'm given a sample size of N in this question. Yeah, then you use the big formula. All right. Then after that, a little bit of calculating, you're good to go. Does anybody need to see this done in the calculator? Or are you all confident that you could do it? Anybody? Don't be shy. If y'all want to see it, just say something. All right. All right, so let's look at it. All right. So first thing you want to do, if you have the TI 36X Pro, all right. If you have the TI 36X Pro, just press that fraction button. That's that button right above the number 7, right? If you don't have that, you have this one, you're going to press alpha F1, right? Alpha F1. Then you're going to choose the first option. You're going to get that little fraction thing right there. Type in the same thing that you have here written on the paper, right? So 12 minus 10.2. Let me go down. This is going to become 1.4 divided by. Then you go second and then square root and then 5. After that, enter. That's simple, right?
36.
I'm sorry? No, this is the 84. Yeah.
So
But
the second.
no. For the 36X Pro, you hit the fraction button. It's right above the number 7, right? And then that's how you get the fraction over the fraction. And then just type in what you have on the paper the same way, right? So 12 minus 10.2 over, but when I say over, you're just going to press a down button to go to the bottom. Then 1.4 divide second square root 5. That's it. So I don't think you have it. Let me see something. All right, you don't have it. So for you, right? Parentheses. So open parentheses, type the first thing in. So 12 minus 10.2, close parentheses, divide, then open parentheses again, 1.4, divide, then second square root 5, close parentheses, close parentheses.
Where was just this one, right?
Yeah,
Okay, just this one.
no, second and then the square root.
This
It's the
one.
yellow. So second,
Not, okay.
yeah, not
this one.
the matrix, this
Hmm.
one. Yeah. And then same answer.
Okay.
Yep. So again, I need to get the tenths and the hundredths place. So this is 2.87 minus probability of z less than. Let's plug in these numbers. Let's try it again. So again, I'm going to go alpha f1, choose the first one, get my fraction right there. Let's type in what you got. 8 minus 10.2. And go down. This is a standard deviation, which is 1.4 divided by second square root of 5. Enter. This is negative 3.51. Right? And then we write back to what we were doing before, right? Look it up in the table, and then that's it. In the interest of time, I'm just gonna do this in the calculator. So I'm gonna draw my distribution. This is gonna be the negative 3.51. This is gonna be the 2.87. This is not drawn to scale. This is not drawn to scale, right? This is just to help me use the calculator, right? Now I'm gonna pretend that I'm standing in the distribution. Right? And then we're going to go from there. To my left is my lower bound. To my right is my upper bound. Right? And then let's do this in the calculator real quick. I know you guys can look this up in the table. I'm just doing this because of time. All right, so we go down to normal CDF. My lower bound is the negative 3.51. My upper bound is the positive 2.87. Mean 0, standard deviation 1. And here we go. Here's my answer. This is the 0.99772347888. Right? Boom. And then that's it. Questions on this? Anybody? Straightforward? All right. For the most part, y'all should have enough information to do y'all homework. Let me see if there's anything direly important for me to say before I wrap it up. It's 4:58 right now. All right, let me just say this last thing, and then we could just call it at that. All right, so what does the central limit theorem tell us, essentially, right? The central limit theorem gives us information about the characteristics of the X bar sampling distribution based on all samples of size n. This is important now. When n is significantly large, meaning n is greater than or equal to 30 in most cases, the central limit theorem tells us that the X bar distribution is approximately normal. The mean of the X bar distribution is mu. the mean of the original X distribution, right? The standard deviation, also known as the standard error of the X bar distribution, is sigma over the square root of n, where sigma is the standard deviation of the X distribution. So let's summarize this information for convenient reference. For almost all X distributions, if we use a random sample of size 30 or larger, the X distribution will be approximately normal. The larger the sample size becomes, the closer the X distribution gets to be normal. Furthermore, we may convert the X distribution to a standard normal distribution, right, using some other formulas. Don't worry about that. All you need to know, right? If you have a sample size that is 30 or bigger, right, then your distribution, theoretically speaking, will be normal, right? Does this work in real life? Hell no, right? If I'm talking about something serious with y'all, like, huh? I can treat it as a normal distribution, right? Whatever it is I'm analyzing, right? But in real life, when I'm dealing with situations like money, for example, right? I'm not gonna trust my investment on just a sample of 30. Like I need a sample of 100, a sample of 1,000, right? Because I need my money back with interest, right? If I'm talking about medicine, right? We're not going to test a drug on 30 people and say it works and then release it across the United States. This ain't COVID-19, right? So, you're gonna test it on like 10,000 people first before you say, all right, this drug might have some benefit, but here's some side effects that we see. All right. That's it. Any questions you guys have? Anybody? So finish your homework. All right. You guys have enough information to do the homework, and that's it. When you see an N, use a formula with the N, the Z formula with the N. When you don't see an N, right, use a regular formula. That's it. All right. N is your sample size. Yeah. Also on your formula sheet, it tells you at the top. Let me show you. So if you look at your formula sheet at the very top, it tells you what N is, sample size. Right? Mhm. I can take this down. We good? All right.